Okay, Ankansh. So what we were doing yesterday? Yesterday we were doing the balancing of equations, right? I gave some equations to practice. Did you practice that? Okay. At least, do you have any doubt in those equations? Can you can you practice that? Do you have any doubt anywhere? Okay then. So today I am going to discuss about the types of chemical reactions. Okay, very important topic, and types of chemical reactions we discuss, right? Okay. So types of chemical reactions. So here we have the four types of chemical reactions are there. Okay, they discussed about the four types of chemical reaction. In that, first one is called chemical combination. What is the first one? Chemical combination. Second one is called chemical decomposition. Chemical decomposition. Okay, and third one is chemical displacement. Chemical displacement. Okay, and fourth one is chemical double displacement. Chemical double displacement. So these are the four types of reactions over there: chemical combination, chemical decomposition, chemical displacement, chemical double displacement. Okay, note down this one. Right. Now, before going to this chemical combination, decomposition, displacement, this one, we discussed two more types of reactions also. One is called exothermic reaction. Exothermic reaction, and second one is endothermic reaction. Okay, exothermic and endothermic reactions are of two types based on energy. Okay, based on energy, the reactions are classified into two types. After this, we go to that. So one is called endothermic and second is called exothermic. Now, do you know what is the exothermic and endothermic reactions? So the reaction in which the heat is liberated, okay, released, such reactions are called exothermic reactions. And endothermic means the reaction in which heat is absorbed, means by taking the heat, if the reaction taking place, then they are called endothermic. Okay, the reaction in which heat is coming out, okay, so that is called as a exothermic reaction. For example, see, if you burn something, okay, like carbon, okay, carbon you are burning, okay, so carbon, when it reacting with oxygen, reacting means what I said, burning, okay, with oxygen, it forms carbon dioxide, and at the same time, okay, we can get heat, yes or no? For example, carbon means what, like coal. So when you burn the coal, then what happens? You get the heat, okay, so meaning is what, it is giving the heat. So when it is giving the heat, okay, so such reactions are called exothermic reactions. So the reaction in which heat is liberated, heat is released, such reactions are called exothermic reactions. And can you give an example for the endothermic reaction? Okay, you know that about the electrolysis of water. Do you know the electrolysis of water? Electrolysis of water means what? So here we take the water and we pass electricity. We pass electricity. The meaning is what? Water is taking the electricity. Okay, it is absorbing the electricity. So by absorbing the electricity, so this water will split into hydrogen and oxygen. Okay, so here the reaction is taking when we pass the electricity. Means electricity is a form of energy. You know that electricity is nothing but a form of energy. So we are giving the energy. Means what? That water is absorbing, taking the energy, and then by using that energy, water is splitting into hydrogen and oxygen. Is this clear to you? So the reaction which takes place, okay, by observing, means by taking the energy, is called the endothermic reaction. And exothermic means what? The energy is liberating out, that is called as a exothermic reaction. Is this clear? And very easy to remember is what? See, you know that did you go to cinema theaters anytime to watch the movie? So when it is entered, cinema theater is there. This is a cinema theater, you think, and here, okay, so this is entrance, you think, okay. So that the near the board, what they write here? Entrance they write. Yes or no? Entrance. Entrance means what? You are going inside. Okay. And then after watching the movie, so near this side doors, they will write exit here. Yes or no? Exit means what? Coming outside. Okay. Entrance means going inside. Exit means coming outside. Like, so here entrance. So starting with which two letters? N. So that's called endothermic. Means what? Energy is going inside. Energy is absorbed. Okay. And exit means coming outside. So you are starting with first two letters or what? X. So exothermic means what? Coming out. So heat is coming out. So energy is coming out. Heat is coming out. The meaning is what? Heat is liberated. Energy is liberated. So such reactions are called exothermic. And endothermic means what? The reaction in which heat is absorbed or taken inside is called endothermic reactions. Is this clear to you? Right. So you can take a screenshot or write this one. Finished? Right. Now then go to the, okay, now previous slide we were discussing about the 4 types of chemical reaction. So now these 4 types of chemical reaction we discuss now. Okay. So first we see the chemical combination. Chemical combination. So chemical combination definition is what? A reaction in which a single product is formed from 2 or more reactants. Okay, a reaction in which 2 or more reactants react to form a single product. So you can write anyhow your wish. So I am writing the definition. See here, a reaction in which a single product okay, is formed from 2 or more reactants. So that's all. This is the definition. Simple definition. No? So see here the definition is what? A reaction in which a single product is formed from 2 or more reactants. So reactants may be 2 or more, but product is only 1. So such type of reaction is called a chemical combination. Is this clear to you? So we can give many examples. So see examples we can give, so many examples we can give. Like, okay, just now I give the carbon burning in oxygen to form the carbon dioxide. So carbon burns in oxygen to form carbon dioxide gas. Okay, so this is an example. So reactants are 2, but product is 1. Okay. Similarly, calcium oxide CaO plus water H2O, that gives rise to calcium hydroxide. So here also you can see here. So here 1, 2. Okay. So 2 reactants are there and 1 product is there. Right. So like this, if two or more reactants, so these are called reactants. This is called a product. So a reaction in which 2 or more reactants combine to form a single product, so that is called a chemical combination. Is this clear to you? And remember that most of the chemical combination reactions are exothermic in nature. How they are? Exothermic in nature means what? In which heat is liberated. So this is also exothermic, this also exothermic. So to represent exothermic, you write the heat here. Okay. So plus heat like this. So plus heat means what? They are exothermic reactions. Okay. Chalo, take the screenshot or write it. Finished? Right. Now then go to the second one is what? The chemical decomposition. Okay. So chemical decomposition. Chemical decomposition is exactly opposite to the chemical combination. So in the chemical combination, what we studied? 2 or more reactants combine to form a single product. Now this is exactly opposite. So what do you write the definition here? Yes. Single product, not reactant. First reactant. First one is reactant, and after that what will form? They are called products. Clear? So you can write a reaction in which a single reactant decomposes. Decomposes means what? Splits, breaks. Decomposes into 2 or more products. 2 or more products. Okay, is called chemical decomposition. So here the reactant will be only single. Reactant will be 1, but products will be more. So such type of reactions are called the decomposition. Means what? This is pen. If I am apply the force, so it breaks into the 2 pieces. So I'll get 2 pieces, right? So like that, one compound, it may breaks into 2 or more substances or 2 or more products. So that is called a chemical decomposition. Clear to you? Now, this chemical decomposition reactions are of 3 types are there. How many types are there? 3 types. First one is called a thermal decomposition. Okay. Second one is called electrolysis. And third one is called photoelectrolysis or photolysis. So see now, 3 are there. Chemical decomposition is of 3 types. One is called thermal decomposition, second one is electrolysis, third one is photolysis. Okay. And one important thing here, see chemical decomposition, most of the chemical decompositions are endothermic reactions. What they are? So for example, see I have this pen, I want to make it 2 pieces. You become 2 pieces means is it become 2 pieces? No, I have to apply some force or energy. So when apply the energy, then it breaking into two pieces. So here also one reacted to splits or to decomposes into two or more products, then it requires some energy. So that's what the chemical decomposition reactions are generally endothermic in nature. Is this clear? Right. So note down or take a screenshot here. Okay. Now we discuss one by one here. So first one is what? A thermal decomposition. So what is with the thermal decomposition? Thermal means what? Thermal means what? Heat. Thermal means what? Heat. If the decomposition reaction taking place due to heat or by passing heat or by observing heat, if one reactant is splitting into two or more pieces or two or more react products, and that is called a thermal decomposition. Is this clear to you? Thermal decomposition. Thermal means what? Heat. By passing heat means by observing the heat. If one reactant decomposes, means splits into two or more products, then that is called thermal decomposition. For thermal decomposition, we can give many examples. In that, the first one is calcium carbonate. What we give? So calcium carbonate formula is CaCO3. Okay. If we heat, so this symbol is for heating. Okay, this symbol for heating. On heating, it decomposes, means what? Splits into calcium oxide and carbon dioxide. Okay, so this is a solid, this is also solid, this is a gas. Okay, so this is one of the reaction. Okay, so calcium carbonate on heating, it decomposes into calcium sulfate and carbon dioxide. Okay. Now, here one more example also we can give. Generally, ferrous sulfate, FeSO4, which is green in color. Which color it is? So, if we heat it, this will decompose into ferric oxide, Fe2O3 plus SO2 plus SO3. Okay. So here you see this is a solid, this of course solid, and this is a gas, this is a gas. Okay. So like this. Now whether it is balanced or not, see, whenever you write the chemical reactions, whatever the chemical equations you write, so whenever you write the chemical equations, am I audible? Whenever you write the chemical equations, you have to write the balanced equations only. Already said no, balance means what? Both the sets and the total number of atoms should be same. So see here, one carbon, two oxygens, and one calcium, here one oxygen, here also, total two oxygens and two hydrogens. So two oxygens, two hydrogens. See, I kept in a bracket and two. So like this, whatever the reactions you write, you have to check whether it is balanced or not. So here also see one calcium, one carbon, three oxygens, 1 plus 2. So 3, balanced. Now here see, here 2 FeSO4 means 2 irons, so 2 irons. And here 2 sulfurs, so here 1 sulfur, here 1 sulfur 2. And here 2 4s are 8 oxygens, 4 2s are 8. So here 3 oxygens plus 2, 5 oxygens plus 3, 8 oxygens. Is this clear to you? 2 Fe means 2 irons are there, no? So here Fe2 means what? For iron we kept 2. Only these 2 belongs to iron. So that's what this is 2 irons. So 2 irons here, 2 irons here. And if I keep the front means 2, if I kept 2 front means what? The meaning is 2 Fe's are there, 2 S means 2 sulfurs are there, and 2 4s are 8 oxygens are there. The meaning is that. Is it clear to you? What? Individually you can write, if you are writing Fe, 2 Fe, if what, you can write 2 Fe. Okay. So here it is compound. So in this compound is formed by combining 2 irons and 3 oxygen atoms. So that's what we write the formula is Fe2O3. Okay. So this is thermal decomposition. Means what? Here reactant is 1. Reactants are 1. But products we are getting many. Okay, 2 or more. So such type of reactions are called decomposition reactions. But here the decomposition is taking place by heating. So this symbol is for heating, I said. By heating. So that's what it is called as a thermal decomposition. Is this clear to you? So these are the examples for thermal decomposition. Now let us see the next okay. Now next one is electrolysis. The second one is what? Electrolysis. The electrolysis means what? Okay. Electrolysis means what? Same, decomposition. Decomposition means what? Splitting. But by passing electricity. If the decomposition means what? Splitting of a chemical compound, one chemical compound into 2 or more, okay, products by passing electricity is called electrolysis. Very important definition. Electrolysis. By passing electricity, if we decompose one substance into 2 or more products. Is this clear to you? And example is what? Water. If we take the water, okay, and pass electricity, okay, take the water and pass electricity, so 2H2O, and here you are passing the electricity, okay, then what happens? It splits into 2H2 plus O2. So here by passing electricity, okay, so that one reactant is decomposing into 2 products. Hence, this is called electrolysis. Is this clear to you? So again you see, you have to check the balance or not. Here 2 2s are, here for 2 is there hydrogens, again front 2 is there. So 2 2s are 4. So here also 2 2s are 4 hydrogens. Here 2 oxygens is there. So here 2 oxygens are there. So like this, always when you write the chemical reaction, that should be balanced. Okay. So this is about the electrolysis. Okay. Now let's come to the third one. Third one is what I said, photolysis. What is that? Photolysis. So here the meaning of photolysis means what? Photo. Photo means what? Light. What is the meaning of photo? Light. Olysis means what? Breaking. Olysis means what? Breaking. So photolysis means what? Breaking of a substance, means decomposition of one substance by light, in presence of light. In presence of light, if the substance breaks, then that is called photolysis. Is this clear to you? So here what happens when you take the silver chloride? What do we take? Silver chloride. Okay, so you take one watch glass. Watch glass means one small, okay, like a small beaker, not beaker. You can take small, small vessel, and in that you take the silver chloride. Okay, silver chloride, and put under the sunlight. Where you put it? Sunlight. So after some time, if you see in that silver chloride, from the silver chloride, the chlorine gas escapes. Okay, chlorine gas, what happens? Escapes. So chlorine gas will escape, and only silver is left over there. Okay, so this is solid, this is solid, this is gas. So here when you are taking the silver chloride and you are putting on the under the sunlight, then what happens? Here sunlight is making to decompose. Decompose means what? Splits, means break the silver chloride into silver and chlorine. As a chlorine is gas, so chlorine gas will escape and only silver is left to us. Is this clear? So here in these cases, if you see, in all these 3 cases, if you see, the reactants are only 1. Okay, reactants are only 1. Okay, but the products, okay, but the products are 2 or 3. Okay, so one reactant is splitting or decomposing into 2 or more products. So this process is called chemical decomposition. If the chemical decomposition takes place in presence of heat, that is called thermal decomposition. If the decomposition is taking place in presence of electricity, that's called electrolysis. If the thermal decomposition is taking place in presence of light, then that is called photolysis. Is this clear to you? Chalo, done. Take the screenshot. I note down this all. Completed? So this is all you have to learn. Don't take the screenshots and leave it. Okay? Now, so with these two types of chemical reactions are done. Now let's go to the third one. What is the third one I said? Chemical displacement, right? So chemical displacement chemical displacement. Chemical displacement definition is what? Okay. A reaction in which more reactive element displaces, okay, displaces less reactive element, from its compound and occupies its place. That's all. Okay. So this already displacement reaction we discussed in the metals and non-metals. Okay. I explained you about the metals and non-metals. Did you remember? Okay. So this metals and non-metals, in the 9th class also we discussed, I think. Acha, okay. So here what happens, for example, if you take a copper sulfate solution, okay. So you take one beaker, this is a beaker, and in this beaker you take some copper sulfate solution. Copper sulfate solution will be blue in color. So take the copper sulfate solution. In that, if you dip one iron nail, okay. So iron nail, this is iron nail. Then what happens after some time, this iron nail becomes brown in color. How it becomes here? Brown or red in color. After some time it becomes brownish red in color, and this copper sulfate solution becomes green in color. How it becomes? So why this happens? Because, so here we are taking the iron, that is Fe, and we are dipping in copper sulfate solution. Formula is CaSO4. So this is solid and this is liquid, okay, or you can say aqueous solution. Now what happens, in this copper and iron is more reactive than the copper. So you see more reactive element displaces. So now what happens, this iron, okay, come and it displaces the copper, okay, that is less reactive element. So now this iron is occupying the copper sulfate place. So this becomes FeSO4 and copper is coming out, okay. So this is aqueous solution, again this is a solid, okay. So here this is blue in color, but it is turning into green in color, okay. So one more reactive element displaces less reactive element from its compound, okay, to form a new substance is called chemical displacement. Is this clear to you, chemical displacement? Now, for example, now you see, for example, if I am taking copper and I am adding in iron sulfate solution. Now, what are the products from here? Yes? But your answer is wrong, okay. So this reaction will not take place. Why? Because what I said, more reactive element displaces less reactive element. Less reactive element do not displaces more reactive element. Iron is more reactive than the copper, so iron can displace the copper, but copper cannot displace the iron. So the reaction will not take place. Is this clear to you? So that's what you have to read the definitions properly. So definitions, if you read what is there, more reactive element displaces less reactive element, but less reactive element do not displace the more reactive element. Clear? Chalo, take the screenshot. So with this we stop today, and in the next class we complete this chapter. Okay? Right, very good. You are joining little late, Kanks. That's what our topic is slowly going. Okay.